So the cosine extension is actually the same as the sine extension pretty much. Yeah, it's even easier because now you have both. You can know how to use the cosine and the sine. So you have more tools at your disposal. So for example, we're just going to find all the missing pieces of this. We'll start looking at this angle because that's the one they give us. For this, the opposite is over here at x. The hypotenuse is obviously here, and this would be its adjacent. For this angle, its opposite would be actually the adjacent, and this would be the adjacent over here. So the opposite is an adjacent switch. But for this angle right now, let's say I don't know how to find this yet because there's a way when we get to tangent. But if I have the adjacent, I can find the hypotenuse. So I'm going to use cosine to start with. I'm going to say cosine of 34.8 is equal to the adjacent side, 10.1, over the hypotenuse. Remember, I can switch the hypotenuse and the cosine there. So the hypotenuse is whatever 10.1 divided by the cosine of 34.8 is. So I go 10.1 divided by, type in the angle, 34.8, hit cosine, then hit equals 12.3. So I have the hypotenuse is 12.3. Now, if I know the hypotenuse, I could use this angle and the sine to find the opposite here, couldn't I? Let's try that. We'll try it a couple different ways. We could also use the Pythagorean theorem, or we could find this angle and use the cosine. By the way, what is this angle here? It would be 90 minus 34.8, so 55.2. So let's try it this way. Let's keep using this angle and say that the sine of 34.8 is equal to x, which is its opposite side, over the hypotenuse, which I just found, 12.3. And then I just multiply both sides by the 12.3, so I get sine of 34.8 times 12.3 should be this side, the opposite side. So 34.8 sine times 12.3, 7.01, let's just call it 7. There we go. Now if you want to double check it, we could have used Pythagorean theorem here to see. We could do 12.3 squared minus 10.1 squared, get an answer and take its square root, and I get 7.01, so yeah, I get the same answer. Or we could use this angle and use cosine again. This is just going through all the possibilities. You could say the cosine of a 55.2 degree angle is equal to the adjacent, which I wouldn't have known, over the hypotenuse, which is 12.3. And so I could have taken cosine of 55.2 times 12.3. Let's see what we get. So 55.2 cosine times 12.3, same number, 7.01 and some change. So no matter what, there's multiple ways to get that number, the missing number. All right, so let's go through. Let's try this one. Ooh, this is interesting. Ooh, actually, let's jump over here. We'll do this one first. So I switched up the examples here. This is example 2. Same kind of thing. I give you the adjacent, and we're looking for the hypotenuse first. So let's use the cosine of 18.2 equals the adjacent, 28.5 over the hypotenuse. And if you remember for this one, just like that, we switch these. So I'm going to have hypotenuse is equal to 28.5 divided by the cosine of 18.2. 30. So the hypotenuse comes out to be 30. Once again, you could use Pythagorean theorem to get this, or you could use the sine. Now that you know the hypotenuse, you could use the sine to get this, or you could use the cosine again, but you'd have to use this angle. By the way, this angle would be 90 minus 18.2. This would be 71.8. I'll use Pythagorean theorem on this, I think. Now, I'll use sine, opposite from that. So I'll go with the sine of 18.2 equals the unknown, I guess I'll call it x, over the hypotenuse, which is 30. So the sine of 18.2 times 30 should give me x. So 18.2 sine times 30 equals 9.37. There we go. And just in case you're worried, 30 squared minus 28.5 squared equals, take the square root, 9.37. Yep, works as well. Okay, so down here in this one, they don't give us either angle. So we do have, if we focus on this angle, we have an adjacent side. Remember, for this side of this angle, this is the adjacent and this is the hypotenuse. So I know that the cosine of the unknown theta is going to be the adjacent 5 over the hypotenuse 11.5. Or that the angle is going to be the inverse cosine of 5 over 11.5. So I get my calculator and I do 5 divided by 11.5, get an answer, and then I do second cosine. That's a 64.2 degree angle, which I can quickly get this one then, just subtract that from 90. That's a 25.8. All right, and then the missing side, once again, Pythagorean theorem might be the easiest way, or you could do, that is the opposite for this angle, so you could do the opposite side over the hypotenuse. I'll use Pythagorean theorem though. I'll go 11.5 squared minus 5 squared, which I know is 25, and then take the square root, and I get this side is 10.4, we'll call it. So same process here. Give this one a shot on your own, and then come back and restart the video and see how you did. I'm going to go with this angle, and this is my adjacent, and this is my hypotenuse. So I'm going to say that the cosine of that angle is the adjacent 1.68 over the hypotenuse 2.36. Means my angle is the inverse cosine of 1.68 divided by 2.36. So theta is going to be 1.68 divided by 2.36. Get an answer. Second cosine, 44.6. So this is 44.6, which means this one is just that minus 90, which is 45.4. I'll go Pythagorean theorem to get this. So 2.36 squared minus 1.68 squared equals, take the square root, 1.66. That makes sense. It's very close to 45 degrees. So these should be very close to the same. Okay.